Hi, welcome to the class video on definitions and examples of crowd computing. This is the agenda for the class. First, I'll give definitions for collective intelligence more generally, and then crowd computing more specifically. Then, um, for the remainder of the semester, actually, going to talk specifically about large-scale deliberation. This class, we'll talk about, what it is. And then in later classes, I talk about why it's important, how well we can do it now using current technology, and the bulk of the class will be on how we can do it better. So let's start with a very simple definition of what is intelligence. I'm going to call it the ability to solve problems. So collective intelligence would be the increase in problem-solving ability that comes when the problem solvers work together. So it's the advantage of multiple people collaborating in some way. And when you think about it, basically all intelligence is collective in some sense. For example, a brain's intelligence is the emergent result of the interactions of the many neurons in the brain. Neurons are very simple problem solvers. As the collective they produce our brains and our intelligence. Transistors on a chip are very simple problem solvers. Collectively, they can give us things like artificial intelligence, large language models. Engineers in a team become more capable as a result of their interaction. The scientific community, similarly, at a larger scale, becomes more capable in terms of pushing forward science and technology as a result of their collective activity and interaction. Citizens in democracy is another example of that. They work together to create legislation, vote on it, and so on. Crowd computing is a subset of collective intelligence, which involves using computers to increase the collective intelligence of groups of humans. And there are literally hundreds of examples of this, and I'll only talk about just a few here to give you a flavor of how impactful and varied crowd computing is in the modern age. One type of crowd computing is what many people call crowdsourcing. And the basic idea is that you have some relatively small task, and then you advertise it to a crowd through some kind of open call, and then one of the workers in the crowd takes on that task. So it's a kind of outsourcing. And the point is to find someone who could do your relatively small task quickly and cheaply. There are a lot of examples of this. One of the ones that's been around the longest is something called Amazon Mechanical Turk, where people advertise a relatively small task on the Amazon Mechanical Turk website. And then they offer often generally a very small reward. Like if you look at this example, the rewards will be on the order of a few cents um, for each task. So the tasks are small. Each person will look at the task, pick one to do, they'll do it, and then they'll get their 10-cent or 40-cent payoff. And companies will put sometimes hundreds or thousands of these tasks, which are called hits or human intelligence tasks, up on the website. So for them, it's a cheap way of doing things, of doing their small tasks that they could not find a cheaper way of doing. Like, for example, tasks which a computer could not easily do. Another example of crowdsourcing is in the world of science. This example is called Galaxy Zoo. It's one of the first uh, citizen science examples. And the challenge here is that in astronomy, um, there are pictures already for millions of galaxies. And in fact, the universe is estimated to have at least 100 billion, if not more, visible galaxies. And so the challenge was to get some basic statistics of the distribution of shapes of these galaxies. You know, some galaxies are smooth, some are spirals, some look like a disk, and so on. And of course, you could, you know, spend the time of your, you know, PhD students and so on to do this. But what they decided to do instead is to create a website where people would look at pictures of the galaxies and then classify them. And then in order to ensure high accuracy, they would have many people classify on, you know, usually 20 or 30 people classify each galaxy, and then whichever galaxy shape was picked the most often, that would be the result that was returned by the system. And what they discovered is that people were willing to do a lot of work on this for free, basically because they wanted to contribute to the progress of science. In this particular example, more than 100,000 volunteers classified over 1 million galaxies in just a few months. And the accuracy of this approach was extremely high when compared to that of you know, professional astronomers. It was on the order of, you know, 99%. And now there are hundreds of citizen science projects like this on a website called Galaxy Zoo because, you know, this initial project was so successful. Another common kind of crowdsourcing application does what we can call aggregating. And the idea is that you have a big task to do, and what you do is you break it into a lot of small tasks and spread these small tasks over a whole bunch of people. Everybody contributes a small part of it, but in aggregate, the result is the big task gets done. So one example of it comes from, I believe it's Somalia. It's called Ushahidi. And the challenge they had was trying to keep track of election violence incidents that occurred in their country. So they, you know, obviously a very big task, and they weren't able to rely on the media or the government, both of which were, um, you know, under government control, which was trying to hide the election violence. And so they had people report incidences of election violence with their smartphones that would give a description and the location of it. And then this was aggregated on a website. And this made it possible to have a level of visibility to the problems of that country that would have otherwise have been impossible. Each person did just a small part of it, and then the website aggregated it so that you had a relatively accurate big picture. And this application was so successful that it is now being used to do things like identify election problems in other countries like the United States. Oh, sorry, it was in Kenya in 2008, and the initial deployment had 45,000 users all contributing. Another example of an aggregation crowd computing application was Google Flu Trends, where what they did is simply check how often people would do a Google search for something having to do with the flu. And then the number of searches of that type would just be aggregated so you'd get a curve showing the number of searches done per day. And it turns out that by aggregating this information, many people providing kind of a clue about flu activity, you got a curve that was extremely highly correlated with the actual incidences of flu as measured by the reports from hospitals. But this was essentially a free way of getting that same information because it was just sort of aggregating what people were doing anyways. Another example is a website called Patients Like Me, which has been applied to try to gather useful, unbiased information about how to um, treat, you know, the incidence and treatment for medical conditions that were not getting a lot of attention from the medical establishment and from the pharmaceutical firms. So, for example, Um, this is the case where they gather together patient reports on bipolar disorder, which is a mental disease, and they just captured for each possible treatment both the popularity of that treatment in terms of how often people reported they used it, as well as the effectiveness, which is how effective people reported the treatment was. And the thing that's super interesting about this, I think, is that if you look at the examples that were both popular and effective, um, they found that treatments like meditation, exercise, journaling, self-tracking, caffeine reduction, those were the ones that were the most effective, while the treatments that were recommended by doctors, who are in turn deeply influenced by pharmaceutical firms, the unpopular and ineffective treatments were the drugs that were being produced by the pharmaceutical firms. So in the absence of this kind of website, um, we probably would not have known uh, that the things that doctors were asking people, recommending people to do, were actually amongst the worst solutions out there. And this was all done, by volunteer contributions from the patients, and so it was just aggregating a lot of small contributions in order to produce this, very interesting and powerful new piece of collective intelligence. Another example of aggregation is Google search. Now, with Google search, people enter in some keywords and then Google returns a list of web pages that um, match those keywords. But the important thing that Google search does, the unique thing, is that they sort those web pages according to how probably useful they are. So the question is, though, how does Google do this? How does Google rank these pages? And it uses an algorithm which it calls PageRank. And the way it works basically is by counting the number of hyperlinks that are made to a given page. So if Google search returns, let's say, 100 pages that all match the keywords you entered, it will sort them according to how many links went to each one of those pages, and then the page which has the most links will go at the top of the Google list. Of course, I'm leaving out the search engine optimization, which people can do to try to increase the prominence of their search result by paying for it. But that's done only to a limited extent. The basic algorithm is based on counting the number of links. And the intuition behind this approach is that websites that have more links from other websites are more likely to be important. And in fact, you could sort of do this recursively and say that if I get a link from a website which has a lot of links, then it's also a positive sign. So getting lots of links means you're important, and it's better if you get the links from websites that are important. So then the question is, though, where do these links come from? Like, where does the source of intelligence come from? And basically, it's from people. People, when they write their web pages, will put in the hyperlinks to the other pages. And all Google did is write some software which goes around through the internet, looking at all the publicly available web pages, and then keeping track of which pages link to which other pages. And so by aggregating the information that people put on the web, Google search was able to build um, a multi-hundred billion dollar company just by harvesting this human collective intelligence. Another example of crowd computing based on aggregation is Wikipedia. Wikipedia's goal is to provide the world's knowledge in your native language for free. And it's been enormously successful in terms of being able to create a vast amount of knowledge online. the recent stats is that there are roughly 68 million articles in Wikipedia, which is 500 times what is stored in Encyclopedia Britannica, which is probably the biggest commercial encyclopedia out there. And it's available in 287 languages. And this corresponds to about 3,500 encyclopedia volumes. And where do these articles come from? They come basically from everybody. They come from volunteer contributors all over the world. Um, in the last month, for example, there were over 115,000 active contributors to Wikipedia, and all of their contributions, each person working on, let's say, a part of an encyclopedia article or contributing a new article, these are all aggregated to produce, this huge knowledge resource. Another example, perhaps even more impactful, is large language models. And as most of you probably know, is that large language models keep track of the statistics of which words are most likely to come given some previous words. So, for example, the sentence "once upon a," the most likely next word, I guess, is probably the word time. Once upon a time. And so large language models will keep track of those kind of statistics. And the large language models are actually neural networks. That's how they implement this statistical um, model. And they were trained with billions of texts from the public internet in order to do what they do, predict what words come next. So this and so this is how large language models are able to answer questions by essentially playing back the average of what everybody on the internet said after the words in your prompt. So where does this knowledge, this information that large language models use come from? It comes from all of us because LLMs are just mimicking the traces of human reasoning, the written traces of human reasoning, in order to give the appearance of knowledge, or like the effect of knowledge. So large language models are another crowd computing success story. Another category of crowd computing is judging. And the idea is that you ask a lot of people to make a judgment, for example, about what's going to happen in the future, a prediction. And the idea is to increase the accuracy of the predictions by getting a lot of people involved, and then, in some sense, getting an average of their predictions or the most common predictions. And, in that way, um, yeah, get more accurate predictions. And um, one example of this is something called the prediction market, where there'll be a question like, for example, who will be elected president of France in 2022? And each possible president would be um, basically be treated as a stock in this market. And so people would buy and sell these stocks. And if people thought that a prediction was likely, they were more likely to buy that stock. And so, and which would drive up the price. So if you looked at the price of each stock, that would correlate with the probability of that prediction coming true. So, in this example, the prediction market showed, months ahead of time that Macron had a 51% chance of winning because that stock had 51% of the value in that market. And there are many prediction market companies. One of them, Hypermind, has run a lot of prediction markets, and they kept track over 5 years of running prediction markets and over 400 questions what was the correlation between the prices a prediction got in the market and how often that prediction came true. And the correlation, as you can see, is almost perfect, which means that um, the prediction prices were a very good predictor of what was actually going to happen. Um, and the timeline for this was typically predicting something a few weeks or as much as a few months ahead of time. So this is a powerful and successful example of using crowds to make judgments, taking advantage of our collective intelligence and aggregating it. Another interesting example of crowd judgment is the case of Kasparov against the world. In 1999, Garry Kasparov, who was the world chess champion and widely considered to be the best chess player in history, played chess versus a crowd. And the crowd, which was quite large and include many thousands of people, would publicly discuss the moves that they might want to make versus Kasparov, and then they would vote, using an online forum, which moves to make. And they're usually about 5,000 votes per move. Now, the crowd did include some chess experts, but none of them in the crowd would have had um, a chance of defeating Kasparov individually, based on their their ratings. And there were also thousands of people in the crowd who were much worse than the experts and like nowhere near Kasparov's ability. Now Kasparov did win the game after 62 moves and 4 months, but he said it was the hardest game he played. And of course, he played with the best people in the world. It was such a notable experience. He even wrote a book about it called Kasparov Against the World. The last category of crowd computing that I'm going to talk about is using crowd computing tools to solve problems. The idea is that you have some tough problem you're trying to solve, you advertise it to a crowd, you make it into a kind of competition, and then from amongst the answers you get from people in the crowd, you select the best one and typically award them some kind of prize. So users submit ideas. There's a selection process. Sometimes it's based on voting by the crowd. Sometimes the customer does it. And then the best ideas bubble up and often are rewarded in some way. One example of this, which it does not actually use money as rewards, is Stack Overflow, which is a question and answer site for programming. People will um, contribute questions, programming questions that they want to have solved, and then other people will propose answers for these questions, and other members of the crowd will rate these answers according to how good they think they are. And people will we'll talk about incentives later on, but um, the incentives are powerful enough that um, answers typically get questions typically get lots of answers, and there's a lot of votes on the answers, and this all happens very quickly. So people have found that Stack Overflow is a very quick and reliable way to get answers for your programming questions for free. Incentive is another example of this, but this one is in the commercial realm. Incentive was first created by Procter and Gamble, which is a major $300 billion consumer products corporation with a 9,000 engineer research division. And they were having a lot of technical problems that they were not able to solve within their own research division, which is already a big remarkable because it was so big and had so many capable engineers. But sort of out of desperation, they decided to put these technical problems up on a website and then offer people prizes for being able to come up with a workable solution. Now, in this case, the prizes were, relatively substantial. They, will be thousands of dollars, though it would still, of course, be um, a, a tiny fraction of what it would cost for Procter and Gamble to solve it. Obviously, because if they could have solved it more cheaply in-house, they would have, but they couldn't. And the interesting thing is, the amazing thing is that by going to the crowd, they are able to achieve a 30% solve rate, which means 30% of the problems they could not solve in-house with their highly paid engineers, they were able to solve for relatively small prizes by accessing just people out there. And we'll talk more about like why this happens later on in the class. To summarize, I'd like to point out that many of the most consequential technology companies of this era are based on crowd computing. For example, Google, of course, makes money in many different ways, but primarily from search. And their search is powered by the collective intelligence, by aggregating the collective intelligence of the crowd. OpenAI and NVIDIA and many other companies have huge market capitalizations based on their development of large language models. Large language models are built by aggregating the knowledge of humanity as expressed by the text that people have put on the internet. Social networks, which have, you know, created some huge companies like Facebook and X, are of course basically just harnessing the power of the people who use them, harnessing their intelligence, harnessing their their ideas and the entertainment they create. You could put YouTube in the same category, actually. Amazon and Netflix, of course, they sell products, but a lot of what makes them attractive to consumers is that they include recommendations for what products and what movies people should buy. And the way they get these recommendations is by harnessing the ratings and the purchasing behavior of other users. So, a big part of what makes Amazon and Netflix successful is them harnessing the collective intelligence of the users of these platforms.